Hi. So in this video, I just wanted to continue where we left off. In the last video, we had learned about the basics of the Unity interface. And so let's just extend that and learn about the basics of Unity scripting. So I'm going to assume that, you guys took the previous course where you had probably learned processing. So you're familiar with basic programming in general, whether you did it in JavaScript or in Java. We're just familiar with the basic things, how to make variables, loops, if statements, switch statements, what are functions, objects, classes, just the basics of it. I'm going to assume that we're all familiar with that. And so let's take a deeper dive into Unity specifically. Since Unity is a game engine, they have their own way of coding things. And they basically provide us with tools that, we want to use to make our game. So to start, all I've done is I've made a scripts folder. The scripts folder is empty. And let's just make a script. So we can right click, create mono behavior script. That is how we make a basic script. I'm just going to call this hello world. And once it's done making it, we can open it by double clicking it. And it should open in our IDE or our text editor. So let's just take a look at what comes with a script when we make one. So to start, I just want to note one thing. When we made this script here, I went to create, and it wasn't just create script, it was create mono behavior script. And this mono behavior thing is very important. Every script in Unity, well, not necessarily every script, but every script that we want to use as a component in something, every script that's going to exist in the game world, it has to derive from mono behavior. Mono behavior is the base object. It is kind of the game object, like the basic part building block in Unity. That is a mono behavior class. So you can see here we have public class, a colon, mono behavior. So that's just saying that hello world is inheriting from mono behavior. And every class we pretty much make is going to inherit from mono behavior. There are some reasons sometimes you might want to make a class that doesn't inherit from mono behavior, but for the most part, 90% of the time, we are going to have our class inherit from mono behavior. On the top here, we see using Unity Engine. That's just telling us that we want to include the Unity Engine scripts. This is where we have a lot of functionality that the engine gives us. And because we inherited from mono behavior, we're also populated with two functions here, void start and void update. Void start is very similar to your processing setup function. It is called once and it just runs once. And update runs once per frame. And this is very similar to your processing's draw function. It runs once every frame. So a lot of the logic of our game is going to go in update. And a lot of the logic of just setting things up, initialization, that's going to go in start. Let's start off by just taking a look at one of the most basic functions we can use. And I'll put it in start, and that is debug.log. I believe in processing this is the same as print or console.log. I don't really remember what the function was, but all this is going to do is print a string to the console. And so I'm just going to print out hello world. And so let's go test this script out. All it is in start, we print out hello world, right? Now, if you remember, I said all scripts that we make are basically going to be components. So I have this SM rubber duck here, and it has a bunch of components, right? This hello world, the script that I just created, because it derives from mono behavior, well, I can use it as a component. I could come here down to add component, search hello, and you see hello world is there. And now I can see right here, my script has been added. So if I was to hit the play button now, we didn't talk about this in the last video, but the way we run our game is to hit this play button. And when the game is running, you'll see we switch from the scenes tab to the game tab, and we're looking through this main camera here. And just to illustrate that, if I was to move this main camera around, so you can see now I moved it, it's tilted, it's moved in my game camera. And more importantly, we have attached this hello world to our duck. If I go to my console, I see hello world prints out because it was printing on the duck. And real quick, we could also pause our game here, our game execution, and we can run it step by step, like frame by frame. This is useful when we're debugging. We might, use it later on in class if we run into troubles. We might not, but good to know that these exist here. And just one more quick important thing to note. I changed this main camera. I moved it while we were playing. When I stop this, it is going to go back to the way it was before. So the changes we make while the game is running do not affect, they don't save. And this is a good and a bad thing. One, you cannot make changes when your game is saving or playing and have it save, but it lets us test things out, right? We can start the game, move stuff around, see how things work out. So when I stop this, you'll see this camera just goes back. Anyway, the important thing here, with all that being sidetracked, is that on start, we printed out hello world, which is what our script wanted us, or what our script said it was going to do. Let's just try printing something out in update. So here I could also print out debug.log, and let's print out hello update. Let's save it and go back. And now when I play it, we can see it's just constantly printing out hello update. In fact, it's printed out over 1,000 times now. And it's just going to keep going, right? Because it's going to print every update. One nice feature that Unity has with its console is next to clear, you can see this collapse button right here. If I click it, it's just going to collapse all of the exact same string. So this hello update, and it just tells us how many times it's printed it out. So rather than it clogging up, your console feed, we can collapse it so that the exact same string is just collapsed into one. And that's a very useful feature. Okay. So now we got things printing out. Let me just delete the start. And let's keep the update print for now. Real quick, I just wanted to talk about variable scope. So, again, just like in processing, we can make variables. If I wanted to make an integer, I just type in int, the name of the variable equals to, and then whatever it's equal to. Same thing I can do with a float, right? Or we could even use a string. Etc. There's a bunch of variable types, but I'm just letting you know, just like we did in processing, the way we make a variable is the type of variable, the name of the variable, and then we initialize it. What is it equal to? I just want to talk about scope real quick. So you can see this variable num or f or stir. I have created that under the class. What that means is these variables can be accessed from any function within the class. On the other hand, if I make a variable here called int l, and I just set it to whatever, this variable is created in start. So what that means is it's only going to be visible to things inside start. So you can see here if I type L, my autocomplete immediately lets me know that it's a local variable. But if I did this in update, it's not giving me that same autocomplete. L isn't a variable here. Instead, it goes on to the other kind of variables we can use. If I was to type num here, however, it is letting me access num because num is a part of the whole class. And so this is a concept of variable scope. Easiest way to think about it is when you make a variable, look at the curly braces around it. Whenever the curly brace that it's around closes, that variable is gone. It no longer exists. And this is also true for things like for loops. If I made a for loop, I'm not going to type out the whole for loop, and I had int I in here. This integer is only there for this for loop. Once we're out of this for loop, it does not exist anymore. So just a very important thing to know. Whatever variables you make, they only exist within the curly braces that they're created in. And this is called variable scope. So when we create a variable inside our class, that variable is accessible to the whole class. These are known as global variables. When we create a variable inside a function, these variables are only accessible to that function itself. These are known as local variables. So it's just, again, just looking at this global variable, instead of printing out hello update, I'm going to print out num. And all I'm going to do is num plus plus at the end of the update loop. So we're going to print out number, increment it by 1. So let's just see this printing out 1, 2, 3, 4, in our console. And I'll set num to be 1. So let's play this. And you can see it's just going to keep printing out. I have collapse here enabled, but it's still going to be printing out different numbers because we're printing out, a new string each time. None of these are the exact same string, so I can't quite collapse them. But you can see this variable is incrementing because we are doing it in the update, so it's happening once every frame. Okay, so that was us using like the basic, print log. These are all basic variables here. Let's take a look at something that's a little more Unity specific, game engine specific, right? One thing I'd mentioned in the last video is every game object, regardless of any of the components that it contains a transform, right? And we can always access this transform. It is one of the global variables that's available to us because we've derived from mono behavior. And we can manipulate our object's transform through code. And, let's take, again, a quick look at that. Let me just delete all this code here. And let's think about how we normally access things. So if you remember from processing, and this is true for pretty much all coding languages, we use the dot operator to access things, right? So you will have your class, dot, maybe some function, maybe some variable. In that same vein, transform is a variable that's available to us in our mono behavior. It comes with this class. So if I type transform, you see it lets me do that. And if I hover over this, it says the transform attached to this game object. So this transform variable refers to the transform component attached to our game object. And if I was to look at this transform has a position, a rotation, a scale. And each position, rotation, scale has an X, a Y, and a Z. So I can access the position, the rotation, or the scale by typing in transform dot position, and you can see again, the autocomplete tells me that it exists. It's the world space position of the transform. Same thing I can do with rotation or scale. So transform has a special function as a part of it too. So we can go to transform. I can type translate. And again, we can read the description here. Moves the transform along its X, Y, Z axes by the value of the translation parameter. So let's just take a look. Let's do transform.translate by, we'll move it on the X axis, which is the forward axis, which can be got by typing in vector3.forward. This is a global variable, again, accessible to anyone. And when we move things in Unity, we'll talk about this a little more when we start getting into our characters. We want to multiply it by the frame's delta time. And what that is just how long it took to render the frame. And the reason we do this is to make our movements all frame rate independent. If you were to think about this update function, just for a quick second, when we say we want to move it by vector3 forward, which is 1 on the x-axis, 0 on the y and the z, it's going to move 1 unit every frame. But my computer might run this at 60 frames a second. Your computer might run this at 120 frames a second. So what that's going to lead to is your computer will have the object moving twice as fast. So this is frame rate dependent because every frame we're telling it how much to move. If we just multiply this by time.delta time, we're basically scaling that value to how long it took to render the frame. And again, we'll look at this a little more when we talk about our character. Just for now, know this is kind of the convention when we start moving things around. Okay, so what we're doing here is on every update, we're translating our thing by 1 on the x-axis, and then we're just multiplying it by time.delta time. Okay, I do apologize. I believe in Unity, forward is 1 on the z-axis. It's the same concept. I just mixed up the x and z-axis. All right, so now if we take a look at our duck, when we play the game, it should just start moving. And you can see there it's going. I'm not sure why it's moving up instead of forward, but point still stands. It is moving 1 on the forward axis every single frame. Ah, I see. Okay, the reason it was moving up, even though we asked it to move forward, is because the object has been rotated by 90 degrees. So if I look at the local pivot, you can see that the z-axis is pointing up. If I was just to rotate this back to 0, the duck doesn't look right, but the z-axis is pointing forward now. So when I run this, it looks like it's not moving, but that's just because it is moving this way. All right, so that's correct. The only reason it wasn't working correctly was because the duck was rotated. I'm going to keep it rotated because we don't really care about its movement. But that's good to know. Okay, so we have this duck moving right now, right? It's moving forward every frame. What if I wanted to control its speed? I wanted to make it go faster or slower. Well, I could just come in here and multiply it by some number. So if I multiplied it by 2, for example, we could say it has a speed of 2, right? Because this forward vector of 1 multiplied by 2, well, that's 2. Or I could change it to 5 or 6. Doesn't matter. But this is not, this isn't good programming. We have variables for this exact reason. So we shouldn't have to come in here and type a number each time. We should associate it with a variable and use that variable here. That way we can also, access the speed variable from other places. So that's exactly what I'm going to do. I'm going to make a new variable called float speed, and I will set it to 4. And here, instead of using 5, I'm just going to use speed. And they should be all fairly similar to, processing. It's just the basics of programming. And now when we come here, we're going to see it moving much faster. There you go. You can see it's moving much faster. And if I wanted to change the speed, I would have to come back in here, and I could change the speed from here. But Unity lets us kind of, there's an easier way of doing this. I could come in here and make this float public. Oops. There you go. And just by making it public, if I go back to my editor, we will now see that speed is now a variable over here. We can see speed equals 4, which is what I set it to initially, but I can change it from here. I can make it 10. And there you go, it's going even faster. What is one big benefit of this? Well, if I had 2 rubber ducks, and I gave one the speed of 2, and the other has a speed of 10, well, now I have 2 copies of the same object, but I can actually set different things to them. I can give them different settings, and this is a very powerful thing, that we're going to make a lot of use out of, because by having, again, as what is essentially a class, and I've made 2 objects, I'm able to edit the options of each object to make them different. So now, this is good, right? We have a variable that's editable, makes our code more modular. It means that we can use this, we can copy paste this duck everywhere. We can change its speeds, give it different options. We're not writing new scripts each time. We're making our one script more modular. And that's like a big point. That's like a good style of programming, is to make things more modular. All right, one downside of this right now is that this variable is public. That means that if anyone else has a reference to me, if there's some other class that knows about Hello World, it has full access to the speed. That other person, they can change the speed. And this is an ideal behavior. If we want the speed changed, we should do it in a methodical way. Again, we will take a look at this more in depth when, as we go along the quarter. But just know it's not really good to have public variables when we don't need them to. The only reason I have this speed public is so that I can see it here. And that's not the best use of this public variable. So in that sense, Unity does give us another option. These are called attributes, and we can put attributes in front of things by using square brackets. And the specific attribute that I'm looking for is serialize field. And what that's going to do is the exact same thing. You're going to see there's no difference here. I can still see the speed here. I can still change it. It's still 2 on one duck, 10 on the other. But this variable is no longer public. So if someone else knows about Hello World, they're not going to be able to see the speed unless we want them to, unless we make a function maybe like get speed, set speed, something like that, they won't have access to the speed anymore. So this serialized field just gives us the benefit of seeing it in the inspector without actually making the variable public. And this is what you guys want to mostly use rather than using a public variable. Now, there are a ton of other attributes you can use in Unity. Unfortunately, there's not like one single place, I'm not sure why, where you can just see these attributes, but as you're looking through tutorials or online documentation, you'll find like these attributes are used a lot, and there's a lot of cool ones. You can do something like header, and we can type in something like player options. And if I go back here, you can see that now we have a little header there, player options. So imagine if you had a bunch of options. This helps us, organize things. We can start putting things in different spaces. And now our designer can come in, and when they look at our script, it's not just a mess of variables. Everything is organized. And again, that's one way to help. There's a ton of other ones you guys can Google. I know from experience, there's things like range, which will let us turn our variable into a slider by telling it, I want it from a range of 20 to 50 or 40 in this case, sorry. And now if I go back and if I set it up correctly, we could see now speed is now a slider, which it makes it, again, just a little more user-friendly, right? We can also do things, I believe, like add a tooltip. This is our player's speed. And this should make it, when I hover over speed, gives me a tooltip. And there you go. You can see a little pop-up there. It's very tiny, but it says this is our player speed. So again, very useful, super cool that these exist. Not the most important, but I would say they're very, very useful and worth using as you start working on a team. Even when you're working alone, these things are helpful just to keep your own mind organized. You might forget something. You might and it's hard to look at things that are unorganized. So, these just help us organize things and makes our script look better in the inspector. Okay, so let us extend on to our script right now. And right now we have it moving. Instead of moving it, let us rotate it. So same thing, just kind of different, right? And again, we have a nice function already built. So if I do a transform, I can just search rotate. This is different from rotation. Rotation is the variable. Rotate is a function. And I want to rotate it on the y-axis. So I'll do vector3.up this time. Again, this is going to rotate it weirdly because our object is rotated weirdly. Doesn't matter. And I'll do it by the speed. And again, we're moving it. We're making a change in its transform. Let's multiply it by time.delta time. And so let's see this rotate work instead. And when we go back to scene, move closer to our object, you can see, well, it's rotating, right? I can even change the speed here. And the speed you can see is changing in real time in the editor. If I make it 100, I can make it 1,000. And when I hit stop, it's going to go back to 10. Again, because those changes are not saved when we are in play mode. Okay, so we have talked about transform a bit, right? And transform is a component, like I said, transform is a part of every game object. And so we have access to it using this special transform variable that's just a part of mono behavior. What if I want to access a component that's not one that comes with the game object, that's not transform, and I want to access something else? You can see this rubber duck here actually has a few other components, right? It has rubber duck, or a mesh filter, sorry, a mesh renderer, it has our script. It also has a material. So one small thing in this material, if I open it up, you can see all I've done is I've made a basic material. Again, we'll take a look at that at some point. And I've given it the color yellow. If I start changing this color, you can see my ducks all change color. What if I wanted to change this color through code? Well, I would need access to the mesh renderer component. And we don't just have a variable in here called mesh renderer. So this is the type of variable. You can see it says class Unity mesh renderer. So this is not a variable inside my inside my class. I just want to make that clear. This is very different to this transform that you see here. If I hover over this transform, you can see if it pops up the tooltip. Yep, there you can see the transform attached to this game object. You can see that this is a variable, which is a little different from this transform, which says class Unity engine transform, which is its own class, right? It's not a variable, it's a class. And the way, again, you can note that is this transform is a small t, this transform is a big T. If we take ourselves back to processing and just programming naming conventions, we always start classes with a capital letter, and all variables are camel-cased, which means they start with a lowercase letter. But when we want to separate the words, we start using uppercase. So for example, if I wanted a variable called my speed, it would be int my, m with a lowercase, and then speed, the s is capitalized to separate the words out. And that's just, again, I'm just noting that, this transform with lowercase is very different to this transform, which is uppercase. This is a class. This is a variable of type transform. They just named them both the exact same. So in that vein, I want access to the mesh render, which we saw was a class. We don't have a variable for it. And I can make a variable here called mesh renderer, and I will call it renderer. But this, again, this doesn't specifically talk about my mesh renderer. It is just I'm just making a variable called mesh renderer of type renderer, and I somehow need to get my mesh renderer. To do that, we have a function in Mono behavior called get component. And all get component does is it'll just get the component. We give it a type of component. It'll just get it. And we can store it into a variable. So I can say renderer equals get component. And then within angle brackets, I would type the name of the component, which in this case is a mesh renderer. And then we put curly braces after because it is a function. And now from here, I can use the renderer dot color. Oh, I apologize. It's renderer dot material dot color, and we can set this to some color. What color would I want it to set it at? Well, let's just comment this out for now, and let's make a color variable up here. So I can do the same way. I can do serialized field. My color, I forgot to give it the variable type, which is color. My color equals to, and we can give it a default of color dot white. And here we'll say renderer dot material dot color equals my color. Now we go back here. And you can see a new variable shows up, my color. I can set it to whatever I want it to be. One thing here, I'm doing this renderer material color in update. I don't really need to do it in update because we only need to select the color once. So I'm just going to put it in the start because we only need to change the color once, right? So on start, we're going to get our mesh render. We're just going to set its color to my color, which defaults to white. And over here, I've just set it to a different color, red. So let's see what happens when we hit start. We can see one of them has turned red and the other has turned brown. Now, just note, because we did do this in start and not update, if I change this color now, it's not going to change because it's not going to set it, right? But as you can see, we have created variables. We've made these variables editable by our designers or by us later on. And we've got a component. We've taken access to a component, the mesh renderer component here. And then we are changing, we're affecting our objects in the world using the start and update method. All right, one last thing I just want to show you guys is just like we've got this mesh render, which is a built-in Unity component, we can also get our scripts in a similar way. So what I'm going to do is I'm going to make another script, call it hello function. And this is just going to have a function that our hello world can call. I'll delete all this code, and I am going to make a public function, public void print me. And all this is going to do is console.log. Oh my. Right, I meant to say debug.log. And I'll say printed from another class. So this is a public function, which means it has, we can access it from another class. And what I'm going to do is have hello world call this hello function, print me function. And to do that, well, first of all, we can attach our hello function into the duck. So you can just drag it like I did there, or you can go into the add component, edit, just two different ways of doing the same thing. And so now this duck, let me delete this duck. This duck has a hello world script and a hello function script. And just like I got this mesh render, we can do the exact same thing for our hello function. So I can make a variable of type hello function, call it function's a keyword, so I'll call it something else. I'll call it other class. In our start, I would do other class equals get component. What is the type of this component? Well, it's a hello function. And in our start, I will call other class.print me. And this other class is a hello function. And print me is going to print this printed from another class. So in our start, this hello world is going to look through our game object, be like, is there a component called hello function? Yes, there is. And it's going to call it. All right, looks like I have an error here. Not sure what it is. Does not contain a definition. Okay, that was a really silly error. The reason was I didn't save this file. This hello function didn't save, so Unity didn't see any of this code. So I just had to save it. Silly error, but something that can happen. We're checking. Make sure we always control S before we get out of there. If your editor doesn't have autosave, like mine just doesn't for some reason. Okay, now when I hit play, our console prints out prints from another class. And so again, I just wanted to note, what we have done here is we have accessed another class, another component, a custom component that we have made, a mono behavior script, from another mono behavior script using this get component. Get component is something we are going to just keep using. And we'll see that from next class when we start building our player onwards. Okay, so I know this has probably been a lot of little things because we're kind of getting our hands on the basics of Unity. We will start approaching other things as and when we need them. We still need to talk about things like collisions, coroutines. There's a lot of little things in Unity. We're going to work with some physics objects when we start making obstacles, and we can build up onto that. But these are the basics of Unity. I would urge everyone just start playing around with this, even start looking up online. There's other good tutorials that just teach you other bits of the basics. There's a lot that Unity provides with us that we can use, so it takes some time to get a handle on it. These are just the most important things I think that we need to know. Making variables, making it so we can edit the variables inside our inspector. That's a very big part of Unity. Accessing other components, again, that's a very big part. Unity is component based, so we need to be able to make changes in components from other components. And finally, some basic functions. We learned that renderer has a material that has a color function. Transform has a rotate, a translate function. So just accessing these functions and using them. Anyway, thanks you for watching.